Notice I have a system here of 3 equations in 3 unknowns, so we will pick any 2 equations and eliminate a variable. Now I'll pick equation 1 and equation 2 because I notice that if I simply add those 2 equations, I notice the y's will subtract out. So I'm adding equation 1 and 2, and watch what happens. 2x plus basically 0 is 2x. Negative 3y plus 3y, that term subtracts out, and then plus 2z is equal to 4 plus 2, or 6. So that's equation 1 plus equation 2. Then normally what we do is we find any other 2 equations and we eliminate the same variable. But looking at these 3 equations, I see that this third equation happens to have no y term in it. So I'll simply write down now equation 3, which is x minus z is equal to negative 5. Now treat this as a system of 2 equations in 2 unknowns, and let's solve this system. To do so, I'll write the first equation down again, 2x plus 2z is equal to 6. The second equation I'll multiply through by 2. So 2 times x is 2x minus 2z is equal to 2 times negative 5, or negative 10. Notice what happens now. 2x plus 2x is 4x. The z's subtract out, and I have 6 minus 10, or negative 4. And if I divide both sides by 4, I'll have that x is negative 1. So I have an x value. It looks like we have one ordered triple solution. The x value is 1. How can we find the corresponding z value? Pick an equation in x's and z's only. I'll go ahead and pick equation 3. Since x is negative 1 minus z is equal to negative 5, I can solve this equation for z. So I'll have negative z is negative 5 plus 1, or negative 4, and if I solve for z, z is 4. So I know z is 4, and how do you think we can find y? Choose any equation now. Here's one in x's and y's only. You'll need an equation containing a y. Let x be negative 1 and or let z be 4. Solve it for y and you'll find your y value. If you do so, you'll find that y is negative 2. So we have an ordered triple solution, and here it is.